Let's visualize the results when triangle EFG. So now we're going to be looking at a different problem. So visualize the result when triangle EFG is reflected over V, which is this line right here. And then it says to form triangle E prime F prime G prime, and then triangle E prime F prime G prime is reflected again over the other one. So if you guys notice here, we've been using reflections to pretty much discover the other two rigid transformations, right? So let's look at this one. Now, again, I'm going to give you guys the opportunity to use the tool. So you guys should be looking at the next link right there. So the first one, again, we want to reflect it across this line, right? So we got to make sure that we're always the same distance to the line of reflection, all right? So we want to do the first one. So triangle EFG is being reflected across line V. So I'm going to start off with the point closest to that, which is F. So that's 3 units away. So I'll put that right there. And then G is 11 units away from the line of reflection. So we're going to put that over there. And then finally, E is 9 units away from the line of reflection. And that becomes our translated, or actually reflected triangle, right? So now again, it says then reflected across line W. So we want to reflect the same triangle EFG across line W. So what we're going to do here is, again, we got to make sure that we're exactly the same distance away from the line of reflection, right? So we're going in this direction and always perpendicular, all right? Meaning we cross like at a T. So here, let's figure out point G. I think that would be the easiest one to figure out. So we're like 1, 2, 1, 2. So right there, approximately, exactly right there. And then this one, I would go 1. So if you notice, I'm counting the little corners. 1, 1, 2, 3, 4, right? So I'm going to count 1, 2, 3, 4. So hopefully that's where I end up at. I think so. Yeah. Seems too close to G. We'll double check right now. Oh, sorry. Wrong one. This one was fine over there. Okay, there we go. So again, we're 1, 2, 3, 4. So 1, 2, 3, 4 right there. Okay, now it looks good. And then the last one, which would be 1, 2, 3, 4, 5, 6 units away, directly across. So 1, 2, 3, 4, 5, 6. So down there. And there we go. So again, a way to double check our answers is we can just click here. So that pretty much the same one. And then to see how we reflect it over the orange line, we can click on the next one. Looks good. So we got all the points right. And then, so is the final image a translation of the original? If not, describe the result. So if you guys notice here, this one got reflected. Does it look like we moved it? Was it a single movement? That's what's important. In this case, we would say it's not a single movement, right? So it looks like the triangle, it is a single movement, but the triangle ended up within a completely different direction. So let's go back to the question. All right, so make sure you guys fill that out right there. So again, in this case, it's not a translation, right? So not a translation. All right, from triangle EFG to triangle E double prime, F double prime, G double prime. All right. So again, make sure you guys take your time to copy this into your notes. There we go. Think I got it right? Yep. So it's E, F, and G prime. And then over here, this is G double prime, E double prime, and F double prime. There we go. Okay, so Amanda noticed that when reflected lines are not parallel, the image was a rotation of the original figure. So this is a rotation, right? So for example, the diagram on the right shows the results when an ice cream cone is rotated about a point. In part A, the center of rotation is at point P, the point of intersection of the lines of reflection. Use a piece of tracing paper. In this case, we can use the app again. So let's go back. So here, point P is down here, right? Down here is point P. You guys see it right there? It's pretty much the point of intersection between those two lines. So if we rotate it, right, we increase the angle. We're rotating about that point. And if you guys notice, we're there. Ended up at 90 degrees, right? So you guys can clearly see how this is rotating about point P, right? And again, you guys are more than welcome to keep playing with the tools until pretty much you get the hang of it. All right, so it says in the center, so for example, diagram, so that's rotation. In part A, the center of rotation is a point P, the point of intersection, right? Well, the tracing paper and resource page are aligned, apply resource. So make sure you guys do that so you can practice tracing the rotation, right? So the rotation of triangle EFG in part A is an example of a 90-degree rotation. The term clockwise refers to the rotation that follows the direction of the hands of a clock, namely, right? So again, the clock goes in this direction, right? It says a rotation of the opposite direction is called counterclockwise. So when we're going in the other way, it's called counterclockwise. Perform the rotation again, noticing how it's like. So again, original of the equation. So we want to see if this is a polygon. So we want to rotate this shape, all right? And again, we can go back to the other tool. It says rotate the L 90 degrees counterclockwise. So counterclockwise, it says drag the green points to create the L shape that is rotated 90 degrees about point Q. So this, you don't want to touch this point because this is where you're rotating it. So if we're going to go to this way, right? So this point is 3 units away. So we're going to move this point 3 units right there. And then we're going to rotate it one more time, 90 degrees. The shape should look pretty much exactly the same, correct? And then this one ends up being here. And then these two are right there. Oops, wrong one. Right there. And then right there. There we go. Okay, so going back. So is the figure a polygon? In this case, we can say yes, it is, right? So yes, figure is a polygon. All right, and if you guys notice, so part E, rotate the polygon counterclockwise by point Q. So again, point Q is right here, and then this point is going to go down 90 degrees, which would be pretty much right there. This point also goes down 90 degrees, so it ends up being right there. This point rotates 90 degrees. Also this one and this one. So this one ends up here, and this one ends up like so, and this. Okay, I think we got it. And again, you can always double check your work, right, using the app. So right there. Let me take this back to where we were. Okay. So if we rotate the at right there, you guys can see we exactly have the same shape. And then this is just for your information. Again, name of the polygon and the number of sides of each polygon.